Cationic and Anionic polymerization by Ami Shah and Anna Martin.
Synthetic polymers are made by connecting repeating units, usually through covalent bonds. The repeating unit is placed in brackets with a letter or number to represent the average number of repeating units in each chain.
Often polymers are classified by the type of reaction used to connect the monomers. Addition polymers are synthesized through addition reactions across a C-C double bond. Addition can occur by a free radical, anionic, or cationic mechanism.
Many side groups can be incorporated into the polymer chain by using a variety of ethylene derivatives. Cationic polymerization only occurs with electron donating side groups. The cationic polymerization mechanism is also a chain reaction. This mechanism process is initiated in the presence of an acid, which transfers a proton to the P bond of a monomer, thereby generating a carbocation. This carbocation cannot be primary. The acid catalyst most often used is formed by treating BF3 with water. The carbocation generated during the initiation stage is then attacked by another monomer in a propagation step, and the process repeats itself, enabling the polymer chain to grow. The function of the electron donating group is to stabilize the carbocation intermediate that is formed after the addition of each monomer to the growing polymer chain. The pi bond of a monomer is protonated, generating a carbocation intermediate. The pi bond of a monomer acts as a nucleophile and attacks the carbocation. This process is then repeated, building up the polymer chain. The polymerization process is terminated when either a base deprotonates the carbocation or a nucleophile attacks the carbocation.
Chain growth polymers form by adding monomer units to the end of the chain one unit at a time. There is only one growth point. Addition polymers are mostly formed by chain growth.
Anionic polymerization only works when electron withdrawing groups are on the monomer. The mechanism is a chain reaction.
A carbon nucleophile initiates the process by attacking the pi bond, generating a carb anion. The carb anion acts as a nucleophile and attacks a monomer, creating a new carb anion. This process is repeating, building up the polymer chain. The polymerization process is terminated when the growing polymer is treated with a weak acid, such as H2O, or with an electrophile, such as CO2. Anionic polymerization is initiated in the presence of a highly reactive anion, such as butyllithium. The anion functions as a nucleophile and attacks the pi bond of a monomer, thereby generating a new carb anion. The carb anion generated during the initiation stage then functions as a microdonor and attacks another monomer. For monomers that undergo anionic polymerization, the process continues until all of the monomers have been consumed. But even after all the monomers have been exhausted, the process is not actually terminated until a suitable acid, such as water, or electrophile such as CO2 is added to the reaction mixture. In the absence of a suitable acid or electrophile, the end of each polymer chain will possess a stabilized carbanion site, and the polymer process can continue if more monomers are added to the reaction mixture. For this reason, polymers generated through this process are often called living polymers.
Superglue is an example of an anionic polymerization. The electron withdrawing groups are so strong, water can act as a nucleophile to start the reaction.
Addition polymers such as polyethylene and polystyrene cannot be converted back into their monomers. Some can be melted and reformed into a desired shape. Another option is to chemically break them into smaller chains similar to the cracking of petroleum. To aid in recycling efforts, polymers are labeled with a number, 1 through 7, to indicate the type of polymer.
These are 3 different examples of polymer recycling. There's a low-density polyethylene, which can be recycled into trash bags, polypropylene, which can be used for ropes or fishing nets and carpets, and then polystyrene, which is styrofoam packaging materials, coat hangers, trash cans, etc.
Please try this example question. Determine whether preparation of the following polymer would be best achieved via cationic addition or anionic addition.